12 and 13, we're going to make our journey all the way through a couple rational functions here. So like we were saying before, we want to look for things to cancel. For the wholes, these do not cancel here. You have to factor first. So that's x squared over x plus 3 and then x minus 3. So we actually see nothing canceling, but our vertical asymptotes then are going to be at x equals negative 3 and x equals 3, because those are our places where we will not have answers for our function, or we will not have values. So this is hard to do. Sorry, I'm trying my best here. But we got negative 3, and then we got 3 here. Those are vertical asymptotes. Remember, we will not cross those. All right, so let's find now, switch to blue, horizontal or oblique asymptote. We do that through long division. So I don't want the factored form. I just want to put the x squared here, and I want the x squared minus 9 out here. It's awesome when these powers match because it's very simple. What times x squared gives me x squared, and that's just 1. So we see that there will be a horizontal asymptote at y equals 1. So I'm going to throw that into my picture here. Okay, so now I'll switch to, let's go back to black, and we'll actually make this sketch. There's a few things we need to look at. If this graph crosses the horizontal asymptote, there will be a value at y equals 1. All right, so what I'm going to do is I'm going to put a y value of 1 back into the function. So I'm going to say y is equal to 1, which is equal to x squared over x squared minus 9. And I'm just going to see if I can get an x value that comes out of this. Multiply both sides by that. I've got x squared minus 9 here. So basically I'm at x squared minus 9 on the left equals x squared. And hopefully we can see there that that is not going to work. Those cancel from both sides. So the answer is no, this will not cross here. All right, so find and plot all intercepts. Well, that means to find the x-intercepts, I would go like this. And I would have x squared over x squared minus 9. Very simple to see that if, again, I multiply both sides by x squared minus 9, that's going to be just 0 equals x squared. So I'm going to get an x value of 0, which obviously means if I started with a y value of 0 here, I got an x value of 0. So this is going to be right there. Okay? Now, here's the deal. Plot points between the asymptotes. You can, if you really want to, you can plot in as many points as you want here to get very comfortable with this. I will tell you that putting a few in will help for your confidence. Like, watch how simple this is. If I literally evaluate, I don't know why I said r, if I evaluate f of 2 here, well, that's going to come out to 2 squared on top, which is 4. I'm literally just putting them in here. And then 4 minus 9 on the bottom, which is negative 5. So that gives you a little confidence. Hey, when there's an x of 2, I'll go down 4/5 and I'm there. What happens if I put in negative 2? Well, actually, that's still going to square the negative 2. You're actually going to get the exact same thing when you plug it in here. So that means at negative 2, you drop to here. So here's the deal. We know the graphs tend towards the asymptotes. So let's see how this sketch goes here. I'll try my best, but this is, it does not do that. This is just hard to write with. And then we go through and we tend towards the asymptote there. This should be a nice smooth curve, but it's not. All right, but we know it's not going to cross up here, so we can shape it up based on our points. Now, either we're going to have a graph up here or we're going to have a graph down here. We know it doesn't cross the horizontal asymptote because of part C there. So all we got to do is pick another one. So I'm going to do f of what most students will do, and I will pick 4. You know, just get to the right of that asymptote. So that'll be 4 squared, 16 on top. And then 16 minus 9 is a 7. And I wrote a 9. 16 minus 9 is a 7. 16 sevenths. Oh, man, what's that? All right, well, that's equivalent to 2. Gets you to 14. And 2 sevenths. So basically, we got to get to 2 and 2 sevenths. So if I go over 4, up 1, 2, and 2 sevenths, I think that's perfect for 2 sevenths. And you can see now, I cannot cross the asymptote. So this is not, all of these points aren't perfect here, okay? But this is a sketch. So basically, once I get up here, I know it's got to tend towards that one and it's got to tend towards this one. All right, so one more thing, we need another point over here. So we do f of negative 4. Hopefully that would make sense. And if you see this now, like think about this, everything's squared. So just like what we did when we did 2 and negative 2, it's still going to come out to 16 sevenths or 2 and 2 sevenths. So over here, negative 4, up 1, 2, and 2 sevenths. Every problem is unique and different. So this is going to tend towards that asymptote, and that's going to, wow, that was a good one, tend towards that asymptote there. All right, I'm going to cut this one. I'll make another video for number 13.